if I had this whole pool filled up. But how convenient if I have 100 grams and I have 100%. If I have all of my 100 grams, and that means that 100 grams equaling 100%, that means 1 gram equals 1%. That's why this step works. If you understand that right now, that's good. If you don't, then don't worry about it for right now, and we'll just move on and use this poem to help us solve problems, and we'll come back to that later. So, what do I need? Percent to grams. That means I'm physically going to take this word percent right here, the symbol. I'm actually going to change 75 grams of carbon, 25 grams of hydrogen. So that's this step. Right? Just did that. Check. What's my next step? To change grams to moles. Well, how do I do that? That's my mole map. 1 mole here. Over here I have grams, right? My mass in grams. What do we pass by to get to that? The periodic table. So I have carbon here and hydrogen here. So let me turn the page so I have way more room to work here, right? And I change this to grams. I'm going to use my train tracks and put the word grams down here, put the word mole up top. On my mole map I have 1 mole in the mole hole, and on my periodic table I have 12.01 grams of carbon. Okay, so I already changed percent to grams. Now I'm in the process of changing grams to moles. I put grams for hydrogen down here, moles up top, 1 mole here. This is 1.01 grams on the periodic table. And I'm going to go ahead, and my answer is 6.24 moles of carbon. And over here, it's 24.75 moles of hydrogen. So that's step 1 and 2. My next step, what's it say to do? My next step, it says divide by small. That means you look at both of these numbers, the 6.24 and the 24.75, and you ask yourself which one's the smallest. Well, it's 6.24. So I'm going to divide both of these by 6.24. That gives me the answer of 1 for carbon and the answer of 3.97, which I'm going to go ahead and just say that's 4 for hydrogen. So if you look, what order did they give this to me in? They gave me the carbon first and the hydrogen second. So that's what I'm going to do. I'm going to write the carbon first and the hydrogen second. And these numbers right here are the numbers that correspond to the subscripts. So it's C1H4 or just CH4. And that is my empirical formula. We're not going to do this step right now. I have a whole other podcast that we'll do for that step, but for right now we're just going to do simple empirical formulas. Now question, is that what this molecule really is? I don't know. It's a simplest whole number ratio. It could be CH4. It could be C2H8. It could be C3H12. But it can't be C9H55 because this does not match the empirical formula. So again, an empirical formula is real good for telling you what it could be and what it can't be. But for right now, that's not what they're asking us. They're asking us simply to find the empirical formula. So the next step is to find the molecular formula. To find out the formula of a molecule, what it actually is. So, what are they asking us in this question? The empirical formula of a compound is CH4. Hey, that's what we just did. So we know the empirical formula, the simplest whole number ratio. If the molar mass is 64 grams per mole, then what is the molecular formula? The molecular formula's mass is 64 grams per mole. You know that. That's what they're telling you here. And so whenever you see a problem like this, what is the molecular formula? You don't know that, do you? Okay? You're going to use this equation here. And you're just going to say me. And M is the molecular mass. And E is the empirical mass. And guess what? They always give this top number to you. Always. So if I come down here and write me, That means this 64 grams per mole is the mass of what my compound really is. Do I know what it is yet? No, I don't. But it really, truly, whatever it really is, has a mass of 64 grams per mole. You know the empirical formula. It's CH4. What's the mass of CH4? Well, let's write this over here. And this is 12.01, and this is 1.01, but there's 4 of them. So when I add that up, I get 12.01 plus 4.04, or I get a mass of 16.05. That's what this adds up to equal, 16.05 grams per mole. That's the mass of my CH4. Now if you look, the mass of what you have in an empirical formula is smaller. Isn't this smaller than this? So that tells me the mass of what it really is heavier than my empirical formula. So if you do your math and you divide, you are going to get 3.98. Well, that's darn close to 4, so we're just going to call it 4. And what does that mean? That means that my compound, CH4, that empirical formula, is 4 times lighter than my actual molecule, or my actual molecule is 4 times heavier. So I'm going to take this CH4 and multiply it by 4, and I'm going to have C4H16. And that is my molecular formula. That's what it actually is. And that makes sense if you look, because my molecular formula is 4 times heavier than my empirical formula. So that's the 4. And if you look, remember when we did glucose, we took a 6 out. What would you have to do to this compound right here to simplify it? Well, you take out a 4, and you would end up with CH4. Okay? One last problem. And this problem is a molecular formula problem. Because if you look at it, it goes, tells you some information, and what's it ask you? Oh, what is a molecular formula? That's your question. You have lots of information here. So what's a molecular formula? Oh, I know. That brings to mind that I should be doing me, right? And they give me a number here, 98.96. Ooh, that's this number up here, isn't it? 98.96 grams per mole. I don't know my empirical mass, though. And guess what? They don't tell me the empirical formula. They're not very nice. They don't say, find the molecular formula, but they do give you this information. What's this information tell you to do? Well, it tells you to do a poem. What's that poem? Percent to grams, grams to moles. Divide by small, then round to whole. They're trying to trick you. You need to find the empirical formula first. So let's go ahead and do that. Remember the process, and if you would like to turn this off and then look at the solution after, you can. So I'm going to physically take all these and change these to the word grams. Because remember, we're going to assume we have 100 grams. That makes each percent equal to a gram. So I just did this first step, percent to grams. Okay, so I come down here and I write 71.65 grams of chlorine, 24.27 grams of carbon, and 4.07 grams of hydrogen. That's my first step. What's my next step? It's to change grams to moles. So I'm going to use my mole map. And in hydrogen's box on the periodic table, there's 1.01, and I'm putting grams down there, and moles up top, there's 1 mole, so I use my periodic table. Grams down here, moles up top, 1 mole in the mole hole, 12.01 grams on the periodic table. Grams down here to cancel, moles up top, because that's where I need to go, 1 mole in the mole hole, and this is 35.45 grams. Now, on my calculator, I should get 2.021, or 2.02, and that's for chlorine, isn't it? Okay. If you're going to write moles of chlorine, you can. And then I get 2.021 or 2.02 here, moles of carbon. right? That's carbon over here. And then I have hydrogen, and hydrogen's 4.04. Now again, if you look, they give you the compound in order. See that? So over to this side here, I'm going to write ClCH. And I'm looking for the little numbers. Even though this says molecular formula, I'm not looking for molecular formula first. I need to find the empirical formula. Because if I don't know the empirical formula, I cannot find the molecular formula. So, what's my next step? My next step is to divide by small. So the smallest out of these sure looks like it's 2.02. So I'm going to divide 2.02 into all these. And I get 1, 1, and 2. And so that's what I come and put over here. 1, 1, and 2. So it's ClCH2. And that's my empirical formula. Right there. Now, that takes me on my way to doing my molecular formula. So how am I going to do that? Well, let's go back to our word problem. In our word problem, we've done this step, right? That's ClCH2. So now this problem that I've done that is exactly like the problem we did over here, isn't it? We don't know the molecular formula, but we do know the empirical formula. So now we need to look at this section of my problem right here. Okay? Since I now have my empirical formula. So let's go over here. And if I know the molar mass, oh look, they give that to me. That's the M in me. Okay? My empirical formula again was ClCH2 from the page before. Right, remember back here? ClCH2. So what's that mean? Let's add this up. Chlorine is 35.45 grams. Carbon is 12.01. And hydrogen is 1.01, but there's two of them. So you add all these numbers up. And then that's going to get you 49.48 grams. That's the mass of my empirical formula. That's the mass of my molar mass of my actual molecular formula. So what's the molecular formula? Well, you divide these into each other and you get 2. So what does that mean? That means you take ClCH2 and you multiply it by 2, because what you really have is twice as heavy as your empirical formula. So your answer should be Cl2 C2H4. So, if you'd like to replay any of this, you can. If not, I've given you all the information you need. You can go back and you can study the molar podcast, and you can look at this podcast, and that's going to be your test. So good luck studying, and I'll see you soon.